Welcome to the practice test. So identify the following critical points. So y equals 8x squared minus 8x plus 6. This is in the form y equals ax squared plus bx plus c. So that means that a is positive 8, b is negative 8, and c is 6. So that's standard form, so that means the y-intercept is at 0, c, so this is at 0, 6. The vertex is where x equals negative b divided by 2a, so negative 8 divided by 2 times negative 8, or negative 8 divided by negative 16 is negative 1/2. And now to find the y value of the vertex, we need to plug in the negative 1/2 and see what we get. So y equals 8 times negative 1/2 squared. Make sure you put that inside the parentheses so that the negative gets squared as well. Minus 8 times negative 1/2 plus 6. And vertex is going to be at negative 1/2, 12. Which is off of our graph. So somewhere up here, y-intercept is at 0, 6. There's my axis of symmetry, so the mirror point will be right there. If we really, really want to, we can find the x-intercepts as well, but for right now, this should be more than enough. And that's number 1. Number 2. So the vertex, now we're in y equals a times x minus h squared plus k, vertex form territory. So h has to be negative 1 and k has to be positive 8. So that is the vertex at negative 1, 8. Negative 1, 8, right up there. The y-intercept is where x equals 0. So I'm actually going to just use my calculator again. So we have negative 2 times 0 plus 1 squared plus 8, and that is 6. So that's the point 0, 6. So right there and right there, something kind of like that. Describe the transformations from the parent function. So if h is negative 1, we went left 1. K is positive 8, so we went up 8. A is negative, so it's reflected. And the other part of A is a 2, so that is stretched by a factor of 2. And that's number 2. Number 3. Identify the critical points of the equation y equals x minus 2 times x plus 4. That is in the form y equals a times x minus p times x minus q. So that tells me that the p value is 2 and the q value is negative 4. So that means my x-intercepts are at 2, 0 and negative 4, 0. Right there and there. The vertex, or the axis of symmetry, is where x equals p plus q divided by 2, or 2 plus a negative 4 divided by 2, or negative 2 divided by 2, or negative 1. So the vertex is at negative 1 something. I know that my axis of symmetry goes through it, so I'll plug in a negative 1. So y equals negative 1 minus 2 times negative 1 plus 4, or negative 9. Negative 1, negative 9, right there. And then the y-intercept is where x equals 0. So 0 minus 2 times 0 plus 4 is negative 8. So 0, negative 8. Right there, and we mirror it, and there's our graph. That's the front page. So write the equation from the graph in any form, vertex, intercept, or standard form. I'm going to go vertex form because I can see that my vertex is up here at 2, 1. So that means that h is 2 and k is 1. So I know that y equals a times x minus h squared plus k, or y equals a times x minus 2 squared plus 1. I also need another point that's somewhere on the graph. I'm going to pick this one out here at 4, negative 3. So I can find what a is. Negative 3 equals a times 4 minus 2 squared plus 1. Or negative 3 equals a times 2 squared plus 1. Or negative 3 equals 4a plus 1. If I subtract 1 from both sides, then negative 4 equals 4a. And dividing by 4, a has to be negative 1. So my final answer for the equation of the graph, y equals negative 1 times x minus 2 squared plus 1. What is a domain? All real numbers. And what is the range? Well, it looks like we're going down from 1, so y has to be less than or equal to 1. Okay, write the equation of this graph. This one I'll do in intercept form. So it looks like we're at negative 2, 0 and negative 4, 0. So that means that p is going to be negative 4 and q is going to be negative 2 this time. So y equals a times x minus a negative 4 would become x plus 4. X minus a negative 2 becomes x plus 2. And I'll pick a value here where we are at negative 3, negative 2. I'll plug those in for x and y so I can find a. So negative 2 equals a times negative 3 plus 4 times negative 3 plus 2. Negative 3 plus 4 is 1. Negative 3 plus 2 is negative 1. So 1 times negative 1 times a is negative a. And if we multiply or divide by negative 1, then we find that a is 2. So y equals 2 times x plus 4 times x plus 2. The domain is still all real numbers. And the range, well, it looks like we are getting bigger than negative 2, so y is greater than or equal to negative 2. Number 6 is like those. What is the quadratic equation of the function that passes through the point 13, 8 and has a vertex of 3, 2? So vertex is 3, 2, so that's hk. Y equals a times x minus 3 squared plus 2. So it passes through 13, 8, so 8 equals a times 13 minus 3 squared plus 2. Or 8 equals a times 10 squared plus 2. If I subtract 2 from both sides, then 6 equals, and 10 squared is 100, a, and 6 divided by 100 is 0.06. So final answer, y equals 0.06 times x minus 3 squared plus 2. Number 7, write the quadratic equation of the function that passes through 14, 4 and has x-intercepts at 2, 0 and 4, 0. I'm actually going to come back to this in a moment because class is about to start. See you guys in the next video.